So n minus 1 times common difference is added to twice the first term. Then we want to take the n by 2 times of that sum. You will get the sum of first n terms. I welcome all of you to another maths lesson. So today we will derive a formula. We will make a formula to find the sum of few terms of an arithmetic progression. So that's what the objective of today's lesson. We will derive a formula to find the sum of first few terms of an arithmetic progression. Then we will use the formula to find the sums. We will practice that formula. So I start with a problem. So we want to find the sum of first 100 positive integers. We want to find the sum of first 100 positive integers or natural numbers. That is, we want to find this sum 1 plus 2 plus 3 plus etc. plus 100 up to 100 we want to find. I use plus between the terms. Okay, that means we are finding the sum. We are not writing the sequence progression. We are taking the sum of the terms of the progression. So 1, 2, 3, 4, etc. That is an AP, right? A list of natural numbers or positive integers makes an arithmetic progression, right? Okay. So 1 plus 2 plus 3 plus etc. plus up to 100 we want to add. Okay. There is a trick to add this to find the sum of natural numbers. This gives you some hints how to derive the formula to find the sum of first n terms of any arithmetic progression. So from this, I'll show you one trick how to add this. Okay. So here we can call this sum as S. S, the first letter of sum. So we denote sum by S. Not only in this arithmetic progression, in any arithmetic progression we can capital letter S to denote the sum of terms. Okay. So to find this sum, we do one trick. We take the same sum in the reverse order. Okay. So same sum S. We need to find S. For that we are applying some tricks. The same sum we start from 100 and we write in reverse order 100 plus. Then which will be the next term if we write the arithmetic progression in reverse order? Next term
99.
Then here 90, which will come 98 plus etc. Which will be the last term? 1. Very good. Okay. Now we will add these two progressions. We'll add. Okay. So S plus S. The equations, we are adding these two equations. So S plus S is
2S.
2S. Very good. Is equal to not 25. Okay. 2S. 2S is equal to. So we want to add the corresponding terms. So 1 plus 100. 1 plus 100 is
101.
101. Then plus 2 plus 99 is
101.
101. And 3 plus 98 is
101.
101, etc. All terms will be like 1 plus 100 plus 100 plus 1. And the final term is again 101. So how many 101s are there?
50.
Only 50?
100.
100. So we can write here 100 times. 100 times 101 are coming. Okay. So we can write adding 100 times 101 means 100 into 101, right? Adding 100 times 101 means 100 into 101. Okay. So this is 2S, not S. And we need to find only S. We don't want the double the sum. We only need S. So to get S, we want to take this into 2 to right side. So what will we get next step? S is equal
Divided by 2.
Divided by 2.
Before that we can multiply this 100 into 101. It's very simple. 100 into 101. What will be the product? So you put 2 zeros, right?
10,100.
10,100 by this into 2. When we move to right side, it will become by 2. So S is equal to what's the half of 10,100?
5050.
Yes, 5,050 will be the answer. Okay. Using the same idea, same trick, we will make a formula to find the sum of first n terms of an arithmetic progression.
Can you explain one more time?
Okay, I shall explain. Okay, so we want to find the sum of first 100 positive integers. Now we know the integers, the sequence of positive integers is an arithmetic progression. The common difference is 1. Okay, so we in another way we can say the sum of first 100 terms of arithmetic progression 1, 2, 3, etc. You can say like so. Okay, so we call the sum 1 plus 2 plus 3 plus etc. up to 100 as S. We take the sum as S. Okay, and we want to find the sum. So if you are counting without any trick, what you have to do, you want to do with the fingers, or you want to add in your mind, or you want to use some calculator. You want to add 1 plus 2 plus 3 plus 4 plus etc. It will take some time. Okay, so using some simple tricks, you can calculate it very fast. So the trick is you take the same sum in reverse order. So addition is commutative, so you can add in any order, no problem. Okay, so the same sum 1 plus 2 plus 3 plus etc. plus 100, you can same way you can say 100 plus 99 plus 98 plus etc. plus 1. The both sums are equal, so you can use the same symbol, same name as for the reverse sum. Both are equal. Okay, so just add these two equations. Now we got two equations, equation number 1 and 2. Just add equation 1 plus equation 2. What will you get? You will get S plus S in the left side. S plus S is 2S. And you add terms in each corresponding positions. The first positions 1 and 100 comes into two equations. So 1 plus 100 is 101. In second place 2 plus 99 again 101. In third place 3 plus 98, okay, again 101. In the fourth place I didn't write, it will be 4 plus 97, again 101. The sum is again 101. If you continue like this, in the middle you will get 40, 50 and 51. The sum will be 101, etc. And the final term will be 100 plus 1, that is 101. So you will get 101 100 times. Now you want to add all these 101. So that means 100 times 101. So you can write 100 into 101. So this is 2S. That is 2 times the sum. Okay, we need only 1 time the sum. So we move into 2 to right side. We divide and we got. I hope you understood. There's another trick to find the sum of the first n natural numbers or positive integer. We will see later. But this idea, this technique you may have seen before in quiz competition or something. You can expect such question. So to find the sum using some tricks. Okay. So now we are going to derive the formula to find the sum of first n terms of any arithmetic progression. Okay, the common difference can be anything. Okay. So I write the general form of arithmetic progression. You know the general form, right? How is that general form? A, then
Plus D. N minus 1 into D.
A plus D. Not general term, general form
A
of
plus
A plus D.
then
A plus
2D.
A plus
A
3D.
plus 3.
3D, okay, etc. So we take only for sum of first n terms. So we don't want to write entire progression here. Our aim is to find the sum of first n terms. The sequence, the last term here, we can write an. For an, we know an, the nth term formula. What's the nth term formula? How can we find the nth term?
A plus n minus 1.
A plus n minus 1. So here we can write a plus n minus 1d. A plus n minus 1d.
Can you say once more?
That's more okay. So our aim is, I shall write here, sum of first n terms. First n terms. Okay. So we want to get a formula to find the sum of first n terms of any arithmetic progression. So we want to get formula. To get a formula, we want to use algebra, the general forms. So we will get a formula to find first n terms. That formula you can apply in any arithmetic progression. Okay. So what is the general form of first n terms of an arithmetic progression? So that's what I wrote here. So first n terms comes like this. First term for any arithmetic progression, you can take the first term as a, then second term will be a plus d, third term will be a plus 2d, fourth term will be a plus 4d. We are finding the sum up to first n terms. So nth term you can write an, but we already know that an is equal to a plus n minus 1d. We have already studied this. It's nth term formula. Okay. So you write the an as a plus n minus 1d here. Okay. So we know here a plus d comes a plus 2 minus 1d. And the third term a plus 2d comes a plus 3 minus 1d. A plus 3 minus 1d is a plus 2d, right? So similarly, the nth term will be a plus n minus 1d. Okay? And we want to find this sum, their sum, these terms we want to add. So we can call S as the sum as a plus the first term plus the second term is a plus d, then plus and plus etc. plus we want to add the last term. What will be the last term? 2d
A plus n minus b.
A plus
Inverse
n minus
1 by 3.
Okay. This is what we want to add. Okay. So for that, we use the same trick we applied for the previous question. The sum of first 100 natural numbers. So you write the sequence in reverse order. So I start a little bit early. Okay. Under A, we write the last term. We take the sum in reverse order. So last term is a plus n minus 1d. So that's what I write here, a plus n minus 1d plus what will be the term just before the last one if you write in reverse order.
A plus n minus 2d.
A plus n minus 2d.
A plus n minus 2d. Very good. A plus
2D.
n minus 2d. Very good. Okay. The last term is a plus n minus 1d. So the term before you want to subtract d. So when we move from right side to left side in an arithmetic progression, you want to subtract the common difference. Okay. So a plus n minus 1d minus d will become a plus n minus 2d. Very good. Okay. What will be the third term when you write from right to left?
N minus 3D. A plus n minus 3D.
A plus n minus 3d. A plus n minus 3d. Okay. Plus etc. plus what will be the last term?
A.
A. Very good. A will be the last term if you write in reverse order. Okay. So we want to add these two sums. Okay. So 1 plus equation 1 plus 2, what will come? S plus S in left side. So 2S, right? 2S is equal to, so first position A in the first sum and A plus n minus 1d in the second sum. So when we add these two, A and A can be written 2A. Okay, so 2A plus n minus 1d, right? Is that clear?
Yes.
Yes.
If you add the corresponding terms in each positions. So first position in the first sum is A and the first term in the second sum is A plus n minus 1d. So if you add A and A can be combined, A plus A is 2A. Then the second term n minus 1d, you write simply write so. Okay. Then the next position, second position, A plus D comes in the top and A plus 2 minus D comes in the bottom. If you add these two, what will you get? A and A you can combine. What will you get?
2A.
2A. Then if you add D and n minus 1 times n minus 2 times D, what will you get?
2D and minus 1.
D and n minus 2D add. So what will you get? You want to add a D and n minus 2D. So what will you get?
2a plus n minus 1.
2A plus n minus 1D. Yes. Okay, look here. I'm writing here. D plus n minus 2 times D we want to add. So just remove the bracket. So D plus n into D and D and minus 2D. Okay. So nd you can write first. Then D minus 2D will become minus 1D. Okay. Minus 1D. Okay. So now you can take a D outside. So it will become n minus 1 times D. Okay, so D plus n minus 2D. Now, no need to write this step. You can do in your mind. D plus n minus 2D become n minus 1 times D. Okay, so here 2A plus n minus 1D, second sum. Okay, and what will be the third sum? The third positions. A plus 2D on top and A plus n minus 3 times D in the bottom. If you add these two, what will you get? 2A plus n minus 1D, the same. 2A plus n minus 1D. They will get the same. Okay. And if you continue in each position, you will get the sum 2A plus n minus 1D, the same. Okay. And finally, what will be this sum? The last position. If you add
n minus 1d.
Yes, the same. 2A plus n minus 1 times D. Okay, so how many times you get the same term? 2A plus n minus 1D, 2A plus n minus 1D?
n times.
Yes. Okay, so there will be n terms. So you can write n times this same sum. Okay, so 2s will be 2A plus n minus 1D is added n times. Okay, so in next step you can write 2s is equal to n times. That means n into you can write in bracket 2A plus n minus 1 times D. Okay, so this is the 2 times the sum. We need only 1 time, right? So we need only s. No, we don't want a double s. Okay, so you write s is equal to, we can move this into 2 to right side. Okay, so you can put all divided by 2, or you can put this by 2 only for n, no problem. Okay, so better you write like this, n by 2 into n by 2 into, yeah, no need to put into sign, because bracket comes out. By default you will get the multiplication sign. Okay, so into 2A plus n minus 1D. Okay, so we got the formula. This is the formula to find the sum of first n terms of any arithmetic progression. S is equal to n by 2 times 2A plus n minus 1D. Okay, so n minus 1 times common difference is added to twice the first term. Then we want to take the n by 2 times of that sum. You will get the sum of first n terms. Okay, you can also write this as Sn. Sn means sum of first n terms. So we got the formula Sn is equal to n by 2 into 2A plus n minus 1 times D. So this is the formula to find the sum of first n terms of any arithmetic progression. Okay, so here you can simplify the formula. So to form some other formula in different situations, you can simply write the formula as, you look here, we got Sn like this. Sn is equal to n by 2 times 2A plus n minus 1 D. Okay, so 2 times A, I will write A plus A. A plus A is 2A, right? Then n minus 1 D. Then n minus 1 D. Okay, so now you look here, A plus n minus 1 D. makes an, right? Makes an.
Yes.
Okay, so you can write like this: Sn is equal to sum of first n terms is equal to n by 2 into
A
inside
plus
bracket a plus an, a plus an. So this is another form of the same formula. So if the nth term is known, if you know that in the previous question, the 100 was the nth term. We want to find up to 100. So the last term is given. Okay. In such situation, you can use this formula. This will be little more easy. In some situation, the nth term may not be given. The question may be like this: find the sum of 25 terms. 25th term is not given. Find the sum of 25 terms of the given arithmetic progression. So in that situation, better you use the first sequence. So we got two formula. Two are same formula. We simplified by applying the an formula, the nth term formula. Yeah. Okay. And if the sequence terminates at an, suppose the sequence is finite and an is equal to the last term L. So you can also write the same formula as Sn is equal to n by 2 into a plus L. L is the last term. So we want to find the sum of all terms in that finite arithmetic progression. So Sn will be n by 2 times a plus L. Okay, so all are same formulas. For some different purpose, we have made some different forms. Okay, so Sn is equal to n by 2 into 2a plus n minus 1d. Very important formula. And there are other forms. Sn is equal to n by 2 into a plus an. So this one you can also say n by 2 times the sum of first term and the nth term. The last one, Sn is equal to n by 2 times the sum of first term and the last term. The suffix n you can put, that's not compulsory. If you put n, it will be fine. Okay, Sn or S, you can write, no problem. The sum of first 10 terms, we will write S10, S suffix 10. When we find the sum of first 100 terms, we will write S100, 100 as the suffix.
Sir, that one is A plus L or A plus 1?
A plus L, A plus L. The last term we denote by L, right? It should be L, small letter L. So before I clear, I shall explain this derivation again. Okay. So we write the first n terms of an arithmetic progression in general form as a comma, a plus d comma, a plus 2d comma, etc. The nth term, we use the nth term formula a plus n minus 1 times d. Now we want to find their sum. So S will be the sum S. We denote by S. S will be a plus d plus, a plus 2d plus, etc. We want to add up to a plus n minus 1d. We don't use comma here. We are adding, so we put plus in between the terms. And to find the sum, we use some technique. We write the same sum in reverse order. Okay, so sum will be same. You can add in any order. Order is not important. Not makes any problem when we add terms. Okay, so we write S is equal to, in reverse order, a plus n minus 1d, the last term in the beginning. Last term means nth term. Okay. Then the last before will be a plus n minus 2d, then a plus n minus 3d, etc. And if you continue, the last nth term in reverse order will be a. Now add these two equations. So in left side, s plus s, 2s, and a plus n minus 1d become 2a plus n minus 1d. And a plus d plus a plus n minus 2d will become 2a plus n minus 1d, the same. Okay, and in each position the sum will be 2a plus n minus 1d, same in the last position. So you can get the same 2a plus n minus 1d added n times. So here n terms are there in both equations. Okay, so you can simply write 2s is equal to n times. That means n into 2a plus n minus 1d. Okay, Now move the into 2 from left to right. You will get n by 2 into 2a plus n minus 1d. So this is the derivation.